Hello and welcome to this new video in the data science series. In today's video, we'll be talking about supervised and unsupervised learning. There are two main methods used in machine learning and artificial intelligence: supervised learning and unsupervised learning. One employs labeled data to aid in the result prediction, while the other does not. This is the major distinction. The two strategies do differ slightly from one another, and there are some crucial places where one performs better than the other. To help you pick the right course of action for your circumstance, this video will explain those distinctions. Before we get started, don't forget to hit that subscribe button and hit the notification bell to stay up to date on all our future videos. Let's start with defining both supervised and unsupervised learning. Supervised learning is a type of machine learning where the algorithm is trained on a labeled dataset. That means the data has been labeled with the correct output. The algorithm then uses this labeled data to make predictions on new unseen data. This type of machine learning is used when we have a clear idea of what we want the algorithm to do, and we have a labeled dataset to train it on. An example of supervised learning algorithm is classifying an email as a spam or not spam. We can train a supervised learning algorithm on a dataset of labeled emails with the label being spam or not spam. Once the algorithm has been trained, we can then give it new unseen emails, and it will use what it has learned to classify them as a spam or not spam. Supervised learning can be separated into two types of problems: classification and regression. Classification includes categorizing data points into different groups, such as distinguishing apples from oranges. These can be applied into real world to identify spam versus non-spam emails. Common classification techniques include decision trees, support vector machines, random forest, and linear classifiers. Regression models are useful for making predictions about numbers based on several data points, such as sales revenue forecast for a certain company. Polynomial regression and linear regression are some common regression algorithms. Let's talk next about unsupervised learning. Unsupervised learning is a type of machine learning where the algorithm is not given any labeled data, and it must find patterns and relationships in the data on its own. Unsupervised learning is used when we don't have a clear idea of what we want the algorithm to do, and we don't have a labeled dataset. Instead, the algorithm must find patterns and relationships in the data on its own. An example of unsupervised learning problem is clustering data points into groups. We can give an unsupervised learning algorithm a dataset of data points, and it will find patterns in the data and group the points into clusters based on these patterns. Unsupervised learning models are used for three main tasks: clustering, association, and dimensionality reduction. Clustering is a data mining technique that is used for grouping unlabeled data based on their similarities or differences. For example, k-means clustering. Association uses different rules to find relationship between variables in a given dataset. These methods are frequently used for market basket analysis and recommendation engines. So what's the main difference between the two? It's labeled data. In supervised learning, the algorithm learns from the training dataset by iteratively making predictions on the data and adjusting for the correct answer. While supervised learning models tend to be more accurate than unsupervised, they require upfront human intervention to label the data appropriately. For example, a supervised learning model can predict how long your commute will be based on the time of day, weather conditions, and so on. But first, you'll have to train it to know that rainy weather conditions can extend the driving time. Unsupervised learning models, in contrast, work on their own to discover the inherent structure of the unlabeled data. Note that they still require some human intervention for validating output variables. For example, an unsupervised learning model can identify that online shoppers often purchase groups of products at the same time. However, a data analyst would need to validate that it makes sense for a recommendation engine to group baby clothes with an order of diaper, applesauce, and sippy cups. So based on what we learned, which is best for your problem? If the goal of the project is to make predictions about a specific target variable based on a set of input variables, and there is a sufficient amount of labeled training data available, then supervised learning may be the best approach. Some of the examples of problems that can be tackled using supervised learning include image classification and spam detection. However, if the goal is to explore the underlying structure of the data and identify patterns or relationships without any predefined labels, then unsupervised learning may be more appropriate. Examples of problems that can be addressed using unsupervised learning include anomaly detection and clustering. In some cases, a combination of both supervised and unsupervised learning techniques may be used to solve a data science problem, and that is known as semi-supervised learning. Thank you for watching. I hope this video helped you understand about unsupervised and supervised learning methods. If you're interested in learning more about data science and how it's being used in the real world, don't forget to hit the subscribe button.